Morning, it's Josh from Mass Gunworks. I was getting ready to do some milling here, and I just wanted to share a few things with you. I'm making a fixture for my lathe. I need to thread a barrel, and I'm gonna hold the chamber in my 5C collet chuck and put a live center in my tailstock to help center up the muzzle end. There's a video I made called "How to Set a Barrel Up in a Lathe," I think, and I go through this procedure. I use it mostly for threading for muzzle brakes, and I do it on rifles that probably are not going to be shot past, 300-400 yards. If the customer is wanting to put on a suppressor or shoot longer distance, if I'm able to, I'll run it through the headstock and use my spider and a dial indicator and a gauge pen in the muzzle to really get things dialed and centered up, be a higher degree of accuracy. Anyway, the concept of this is it's basically a aluminum tube that's got two sets of 4 bolts that are 180 degrees to each other. And what this is going to allow me to do is have something holding the barrel centered in the steady rest without actually having the steady rest touching the barrel. And the reason that's important for this application is the barrel that I'm working on has some special features that have been formed in the outside of it. And if I just put it in the steady rest, I have a steady rest that has bearings instead of just the brass ends. So I really don't know the advantage of it, to be honest with you. But anyway, I don't want to mar up the guy's barrel. So because it's kind of an odd shape now, I don't want to get any chatter while it's going around. So I'm going to use this thing I'm making to prevent that. The concept of it came from a guy on YouTube called Ray's Garage. He's got a pretty neat channel. Makes some cool stuff out of aluminum. So I'm kind of stealing his idea. But anyway, I've got a round part that I need to drill 4 holes in, 2 sets of 2, and they need to be opposed 180 degrees. So what I've got here, I have a couple options, and I'm going to do it one way. I've done it the other way before, but I'm gonna do it this way. So one way is you got a V block, okay? And put the V block in my vise. Get this out of the way. Put the V block in the vise, and then I can put the round part up against the movable jaw, have the V block on the stationary jaw, and I can clamp it and it'll hold that in place. And then I can drill a hole all the way through after I use my center here to center it up, and that takes care of 2 holes. And then I can use a drill bit and turn the part 180 degrees. And believe it or not, the human eye is actually a fairly accurate gauge of things once it's trained to know what it's looking at. So if I run that drill bit through there, that gives me a reference, and I can somewhat accurately get that round part moved, from 12 and 6 to 3 and 9. Okay. For this project, the exactness of all 4 of those holes being 90 degrees to the center isn't really a huge deal. But I showed you guys this in the video series I did about fluting a barrel. I have this indexing head. So what I've chosen to do is grip the inside surface right here with the jaws, and I've faced this surface and this surface, so I know they're parallel to the bore. And then I've got a machinist jack right here set up on a 1-2-3 block. I got a little bit of stick out here off the chuck, so as I drill, because this is aluminum, it may not be as bad as if it was like, you know, 304 stainless, but I am going to get some flex. So I want to support the end of this so it doesn't flex down too much, okay? And what this is going to allow me to do is get my holes exactly 180 degrees apart, and I can drill one hole at a time. So what I'm going to do here, I'm going to set this camera up on the tool cart that I have right back there, and just kind of show you guys the operation of drilling to the holes, so you get the idea. And then I'm going to cut away and I'll come back and show you the finished product, how it mounts up in the lathe. So get this set up. By the way, this machinist jack I'm using is a Starrett jack screw set, and it's number S191. So if anybody's curious, wants to look one of those up on eBay. I got pretty lucky. I got a hold of a bunch of tools from a deceased machinist from his son, who's a friend of mine from high school. And it's unfortunate that his father passed away, but we made a deal. I built him a AR-15, and he gave me his dad's tools, so it worked out pretty good. In the background, you're gonna hear my dogs. Got an old one who's a little bit angry. A bunch of young puppies running around. Let me move this camera. Sam.
No.
Shut that light off so y'all can see a little bit better. Okay. First thing we're going to do is touch off the front. Get our DRO turned on. Zeros set. Okay. I believe the center is 200 thousandths wide. Yep. I always like to verify stuff, even if I think I know it. I like to verify it. So That is 200 thou, so we're going to go in 100,000. Should put us centered over the wiggler. There's 100. Centered. And I need to move in 322 thousandths to be centered over my hole, plus the 100 thousandths for the center of my center finder. I was wrong, it was 332, so we're going to go 432. Okay, we're at 432. And that is where we want to be with that. Okay. All right, now we're going to attempt to find our outside edges. Now this part is wide enough. I may have a little trouble with that. So. Nope, I think we're going to be okay. All right. So the trick with a lot of this stuff is just to be consistent. Okay, so if you notice, I may not have been down here close to the center line and the widest point of the circle, but what I did is I picked an area that was closest that I could easily reach, touched off, and then instead of raising up and coming over and coming back down, I went out and left the quill same level and moved it. That way I'm getting a consistent touch point on each side. Now what I'm going to do is just divide my my measurement that I got. It was 2 inches 670 thousandths, and that'll give me my center point left to right. So pull out my calculator here. So we need to be at 1 inch 305, and that is center of our part on our y-axis. There we are, 1 inch 305. That appears to be I'm going to do that again because I don't trust it. I think I missed a number. All right. Let's see. 34. All right, I like that a lot better. I need to drop my table a little bit. Okay, so we're going to be drilling a M10 105 for these brass tip screws. An M10 105 requires a 8.5 millimeter drill bit or a letter Q in the English system. Letter Q drill is within 2/1000ths of an inch of the 8.5 millimeter, so it's really okay. So we're going to get ourselves a center drill. One thing I neglected to point out here, I need to be somewhat careful about where I place these holes because so I marked the center of this so I know where the steady rest is pretty well going to be at. Okay, I need to watch how close to the center I get because as this turns, the steady rest is going to be stationary, and I do not want these bolt heads pinging off the arms of the steady rest. So I need to make sure that I'm paying attention to my clearances. So we're going to come down, we're going to make our center point hole after I tighten the chuck. Okay, now we're going to come down and make our center point hole. A little bit of schmutz. So what happened there is the drill bit started to break through the bottom of the hole, and the tips on the flutes caught, bound up the drill. So as you're drilling, you can hear changes in the sounds that the metals make as they're working against each other. Okay, and as I got close to the bottom of that hole, there was this high-pitched whine that started, and the closer I got to popping through, the pitch changed, and I could hear it, you know, get close to the bottom. Then when, like I said, when it popped through, those flutes caught, and it bound up the drill and was spinning in the chuck. So I backed out, tightened the chuck up, came back down. Now we're going to tap. There's a couple ways you can guide a tap in. I have a spring-loaded tap guide. This tap does not have a hole or a point drilled, so it's not really going to be of an advantage for me to use that. So the other thing you can do is just take your drill chuck, get the jaws out of the way, and use the body to kind of center things up, you know. Okay. Now, that being said, I do have a brand new tap that I just bought that has center in it. So for the sake of video, let me go get that. I'll show you guys how that works. Okay, I got my other M10-105 tap, and if you'll see the back here, there's a center drill hole. All right, this is a spring-loaded tap guide, and this end has a center hole as well. So if you have a tap that has a like a 60-degree point on the top, like say this center drill is our tap, we can get right down here on the top. It'll center in that hole and push it down, keep the tap centered up. There is a Allen head screw here, and I'm going to flip this around. The way this works is take this out, there's a spring, okay. Flip it around, got the point, drop it back in, spring in, your retainer screw here. This can be a little fun to put back together. You know, you got springs and screws and sharp pointy things. And you just tension it up. You don't need to tension it much. So we're going to put this in the drill chuck, tighten that down, and we're going to use the drill chuck and the tap guide to guide the tap. If you're curious what I'm using, this is just WD-40. WD-40 is a good lubricant for aluminum. Okay, so I need to drop my table just a little bit. All right, like I said, we're gonna come down. I was gonna catch that, hold it, and we're gonna tap our hole. As you tap, it's important to break your chip. So I like to do like 1.5, 2 turns, and then half a turn back. We can do that now. There's all kinds of magic stuff you can use for lubricating taps. There's tap magic, there's viper's venom, there's some specialized cutting fluids for aluminum. I have a can of this green stuff. Now if you notice, that's starting to move my part just a little bit. Okay, so before I go around and do the other holes, I'm just gonna make sure that that's good and tight and centered back up. Okay, that way I don't get a bunch of wobble while I'm drilling the next one. All right, that's good. Back this baby out. One thing I prefer to do after I drill and thread a hole is come back with a deburr and deburr it. You don't have to do that in the machine. Soft metal like this, you can do it by hand. It just saves a step, saves a little bit of time in the machine. Okay. Now, what you just witnessed was one of the weak points of this setup, because as I went to tap, it started moving around a little bit on the chuck. So if we did this in the vise, it would definitely be a little bit more solid as far as its ability to hold. And that being said, you can, it'd be a pain in the butt to set it up, but you can move this whole setup over to the vise and use your vise to hold things steady. So what we're going to do now is we're going to rotate this 180 degrees. Okay, so I'm going to take the screw jack out. And like I said before, I'm not going to lose my 0-point orientation by doing this, but I'm going to loosen this up just a little bit, verify it's tight, tighten it back up. Now I did lose my 0 point. So now that we've had that failure, way to fix that, you got to re-verify or whatever. So we can take our tap. All is not lost. This tap is going to have a fairly snug fit in this hole. I'm going to come down with my drill chuck. Tighten up my drill jaws. On that, you hold that. Going to loosen this up, or unloosen if you prefer. Verify that's good and tight there. Okay, we're going, when I'm gripping the inside of a part, I sometimes forget what direction I need to turn the key, and that makes for some fun. So there's that. Okay. Crisis averted. All right, so again, going 180 degrees. Clamps are loose. All right. Okay, at 180. Do it all over. Stub drill. Getting a little ahead of myself. I need to put my machinist jack back in place. Okay. Now we go. Having some interesting problems today. Chuck did not get tightened up. You'll notice I'm doing something called peck drilling. So, excuse me. Three puppies, one got left behind and he was not happy. So anyways, I was doing what's called peck drilling. So you come down, you back off a little bit, you come down, you back off a little bit, you come down, you back off a little bit. What that does is it breaks that chip off so you don't have a big old string of bird's nests coming out at you, because some of these chips can be pretty sharp and they will cut you right now. Okay, that's the basic concept. I got 2 more holes to drill. My battery's running low, so what I'm gonna do is I'm gonna cut the video feed here. I'll come back, I'll show you what it looks like when it's all done, and I'll show you how it gets set up in the lathe. So. Hey, it's Josh back again. Finally got the fixture finished up. We're at the lathe, and I wanted to show you guys how it turned out and kind of the purpose behind it. So first thing, I want to get real close in on this barrel, and it's kind of hard to see, but it has a bunch of flat spots milled on it in a spiral formation. So it's not round. It's got those flats, contours. So it's difficult for me to put this into my lathe the way I have it set up. So the tenon that slips into the receiver on the 1022 is a 11/16 and it's machined concentric to the bore of the rifle. So we grip that in a collet and a collet chuck. What I've done is I've come over here and I've got a live center in here, and this is mainly just for end support and to help, you know, center up the other end. I typically, when I do a barrel like this, I don't have to worry about the features that are cut on the outside of the barrel because it's round. So I'll make a slip collar. Okay, if I've got a barrel that's got a real thin profile. But you know, I get sick of making a million slip collars for all these different kinds of barrels. So I've got this fixture. It's kind of a cat's head concept. So it's 1.25" ID in here, and then I've got 2 sets of 4 holes, and the holes are exactly 90 degrees all the way around the circumference, and they are offset. So like these 2 and this one over in the middle. And I use these out here as my main hold, and then these back here just support. So what I'll do is I'll start with the steady rest open, and I'll take a dial indicator and I'll put it here and here, and I'll get this fixture running as true as possible. And I will then get the steady rest set up to hold it. So as the barrel turns, the steady rest is supporting this, which is supporting the barrel, and I'm able to get good hold without damaging any of the exterior features on the barrel. Now, I've taken some painter's tape and I've wrapped it around the barrel, because even though these are brass, I don't want to mar this finish in any way. Okay, so basically what we do from here is I use the center to support the end while I get it cut down to my needed diameter. This is going to be at a 1/2 28 thread pitch, so I got a good little bit to take off, because I think this is a 7/8 diameter barrel. I'll get my threads cut, and then when I go to recrown, because I cut this off with a bandsaw, I'm going to have to remove the center. Well, as soon as I do that, I don't have any support other than the steady rest, and I want to make sure that I've got everything, you know, good and centered up still, so I can profile the end properly and get the crown that the customer desires. So it seems like a lot of rigmarole, as my grandfather would say, to get from point A to point B, but there's a lot more that I have to think about than just popping a piece of tubing in here and machining some features on it. I got to be cognizant of the exterior finish and not damaging any exterior features or any of that stuff. So this is a little bit more difficult setup, but for the application that I'm needing to do, it is a little more user friendly than having to machine a bunch of these slip collars for every diameter barrel imaginable. Again, there's a guy, his channel is called Ray's Garage. He's got a good video about making one of these. Kind of goes through the concept of it as well. But I want to give him a shout out and a thank you for putting this on the YouTubes, because it's something that I had often wondered if it would work, and he proved the concept. So anyway, I'm going to thread this barrel and go inside and drink some coffee. So hope you guys have a good day. Hope you enjoyed that. Hope you learned something. I love hearing comments from you. If you like this, give me a thumbs up. Please subscribe. Enjoy getting the subscribers. And if there's other things that you'd like to see me do, see me explain, set up, leave it in the comments, or you can email it to me, maskgunworks@gmail.com. So hope you have a good day. I'll talk to you later.